Hi guys, doing the Chapter 8 video review here. All the calculations are the exact same as they were in Chapters 6 and 7, so you don't really need to know how to do the calculations for all these things. All you really need to know is which reg you need to use for each graph, and that would be the linreg, expreg, and pwrreg. This one I know for a fact is 0. I think this one's the one right below it. It's alpha, the alpha key, and the only thing you really need to know is which one do you need to use for one of these? Great question. So for linear, obviously, straight line, if you connect the dots, kind of looks like this. Or, linear means just roughly a straight line. It's not going to be nice and neat like this, knowing Mr. Farmer. It's just going to be all scattered and nasty, but there's no curve. That's pretty much the thing that makes it different. And the equation is y hat equals a plus bx. You all should know that. Think of it just as y equals mx plus b. It's the exact same equation except the different letters and stuff to confuse you. Exponential will look like this if you connect the dots, and if the dots are just like this, that's what it would look like. So why is it called an exponential? Okay, if you look at the equation, y equals a times b to the power of x, x is the exponent. So if x is the exponential, you use exponential function to describe it. And that's if he just gives you this. If you just have something that looks like this, roughly, then you know it's exponential. You're going to plug it into your exp reg. Okay? Exponential, just remember x is the exponent. B to the, x exponent. X changes. And the reason why it does this is that, imagine you have b is 1. Okay, so you have 1 to the power of, say, x is 2. Or 1 here. So that's 1, 1. Power of 2, 1, 2. It goes up very quickly because x is changing. So like if you do 3 to the first power, it's 3. 3 to the second power, it's 9. 3 to the 7th power is like some thousand something. Okay? So it goes up very quickly from from a square to a 7th power. Not big difference numerically, but it does this kind of shape. So that's why it makes that shape. It's important to understand that. For the power, similar kind of graph. Imagine this kind of just looks pretty similar. I understand that can be confusing. Just remember, power is going to be kind of like going outwards more. This goes upwards more, but this goes outwards. And the reason for that is also, again, in the equation. This time, for the power function, you have y equals a times x to the b power. So it's simply to remember that b is being to some power. That's always the same number there. Say that's a square. It's going to be a times x squared. It's always going to be that specified number, part b, number b, every single time in this specific example. Unlike this one where x changes. So it's x to the power of b. That's why it's called a power function. And the reason why it does this kind of shape is pretty simple as well. Imagine you have x squared right down here, x to the third, x to the fourth, x to the fifth. Not x to the fifth, that's this. You have x squared, so 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. It just increases pretty close to just that way. The x values increase more than the y values. That's important to recognize there. While this one, the y values increase a lot more than the x values. Just imagine that, b to the power of x. If this is an eighth, y is going to be huge. However, if this is 8, they're still going to be pretty close to each other. So this one would be using the linreg function in your calculator, a plus bx. It's important to use that one. This one would be using the exp reg, which I'll write down so you guys can see. It looks just like this. Just like that. That should be 0. I know for a fact it's 0. Power is just going to be pwr reg, and it's the one right underneath exponential reg, and I believe it is the alpha key. Okay? And you just use it depending on what graph. And if it says this is a power function, it gives you this equation, what kind of function is it? This is a power function because it's x to the b power. This is x is the exponent, and this is linear because there are no exponents at all. So You just need to really differentiate between the three. Otherwise, the math is the exact same as last chapters. So, I don't know. Good luck, guys. I mean, I'm going to have some trouble with this test, to be honest. It's confusing with all this shit to do. Bye.